Ang topic natin ngayon is about Reynolds Number, na bahagi ng ating Fluid Mechanics lecture videos. Napag-aralan natin sa previous video natin ang ginawang experiment ni Osborne-Reynolds. Well, nakita dito sa experiment ni Osborne-Reynolds na hindi lang pala velocity ang factor for transition from laminar to turbulent flow. Nakita sa experiment na to na factor din pala is yung density, viscosity, and even yung diameter ng pipe. And dahil sa experiment na to, na-develop ang formula na ito ni Osborne-Reynolds na tinawag na Reynolds Number, which is NRE is equal to rho dV over mu, kung saan yung NRE is our Reynolds number, U is the density of the fluid, D is the diameter of the pipe, V is the average velocity of the fluid, and mu is the viscosity of the fluid. In general, Reynolds number is the ratio of inertial force over the viscous force. Reynolds number helps us to predict if flow is laminar or turbulent. And take note that Reynolds number is a dimensionless number. So that is why important dito yung consistency ng ating dimensions. Dahil at the end, maka-cancel out ang lahat ng ating units and we will end up with a dimensionless value. Well, we learned that in laminar flow, our fluid is traveling smoothly and generally in one direction. So we learned that if this is our fluid, even meron tayo ditong disturbance na makaka-apekto sa kanyang flow, eventually it will come back to its original flow. Well, considering this straight circular pipe, dito sa laminar flow, our Reynolds number is less than 2,100. In here, viscous force is more dominant than the inertial force. As you can see sa formula natin ng Reynolds number, dahil mababa ang value ng ating Reynolds number, ibig sabihin mas dominant ang ating viscous force compared sa ating inertial force. Therefore, it is easier for fluids with higher viscosity na magkaroon ng laminar flow. And then considering naman yung turbulent flow, this will happen if our Reynolds number is greater than 4,000. And on this case, inertial force is more dominant than the viscous force. Dahil if our inertial force is mas mataas compared sa ating viscous force, magiging mataas talaga yung value ng ating Reynolds number. Therefore, turbulent flow is easier for fluids with lower viscosity. Now, if you remember in our lecture about laminar and turbulent flow, we mentioned that if a fluid is in contact with a disturbance, it will create an eddy. And as it goes along the pipe, palaki ng palaki yung ating eddies. Makikita niyo yan sa example video na to. So dito, from small eddies, palaki siya ng palaki up to this point na malaki na masyado yung ating eddy. Well, dito natin marirealize kung bakit important yung diameter pagdating sa calculation ng Reynolds number. The diameter is important because it determines how big the eddies can be. Dahil yung diameter ng ating pipe ang nagsisilbing limit para sa ating eddy na mag-build up. In general, turbulent flow is not usually desirable due to the increase of flow resistance or the increase of the hydraulic losses. And then you might wonder, paano naman yung in between 2,100 and 4,000? Well, in this region, we have a mixed laminar and turbulent flow. And this is what we call the transition flow. Katulad ng nakikita natin dito sa video natin, meron tayo ditong mix ng laminar and turbulent flow and it's not easy to predict if the flow will be laminar or will be turbulent. It is usually with turbulence in the center of the pipe and laminar flow near the edges. Each of these flows behave in different manners in terms of their frictional energy loss while flowing and have different equations that predict their behavior. So, I hope naging malinaw na sa atin what's the purpose of Reynolds number. Nagagamit natin ito to predict if our flow will be laminar or turbulent flow. So, let us start solving this problem. Bago tayo magpatuloy sa ating discussion, we would like to ask for your support to subscribe to our YouTube channel. Please click on the notification bell para lagi kayong updated sa mga ipopost naming mga video. We also like to invite you to register sa aming website, www.enginerds.org. Our website is an online community for Filipino engineers engineering student, and STEM students. Water at 303 Kelvin is flowing at the rate of 10 gallons per minute. In a circular pipe having an inside diameter of 2.067 inches, calculate the Reynolds number and determine if the flow is laminar or turbulent. Water at 303 Kelvin is having a density of 996 kg per cubic meter and viscosity of 8.007 times 10 to the negative 4 Pascal seconds. Okay, so simulan natin yung ating calculation. Para makuha natin yung Reynolds number, we have to use our formula, which is equal to rho dV over mu. Well, we have our density, we have our diameter, and we have our viscosity, but we do not have itong ating flow rate, no? Itong ating velocity, I mean. But given yung flow rate natin, which is 10 gallons per minute. Well, as I said earlier, dapat consistent yung ating units because Reynolds number is a dimensionless number. So, we have our viscosity, which is equal to 8.007 times 10 to the negative 4 Pascal seconds. And this is also equal to 8.007 times 10 to the negative 4 kilogram per meter seconds. Okay? And then our density is equal to 996 kilogram per cubic meter. Now, para makuha natin yung velocity natin, we know that velocity times area is equal to the flow rate, di ba? Therefore, our velocity is equal to flow rate over the area. This is the cross-sectional area ng ating pipe. So that means we need to get the cross-sectional area ng ating pipe para makuha natin ang ating velocity. But first, kunin natin yung diameter natin and convert it into SI system, no? We will use SI system because anyway, our viscosity and our density is already in SI system. So our diameter is equal to 2.067 inches. Yan ang ating given. Kung convert natin ngayon siya into meter. So we'll have, in 1 foot, we have 12 inches. And then in 1 meter, we have 3.2808 feet. So we have here 1 meter over 3.2808 feet. Okay? So, 2.067 divided by 12 and divided by 3.2808 feet, we have 0.0525 meter. Okay, so using this diameter, makukuha natin yun yung cross-sectional area ng ating pipe. So, our area is equal to pi d squared over 4. So, substitute natin yung ating diameter. We'll have here pi 0.0525 meter squared over 4. So, 5 times the squared of 0.0525 divided by 4 is equal to 0.00216 square meter. Okay, so nakuha na natin yung area, no? Kailangan naman natin ngayon makuha is itong ating flow rate because as of now, our flow rate is in gallons per minute. So, convertin natin siya sa SI unit. So, we have our flow rate is equal to 10 gallons per minute. Okay, so meron na tayo sa taas sa ating given ng conversion ng gallons to cubic feet. Okay, so we have in 1 cubic feet, we have 7.491 gallons. Okay, and then i-convert natin itong ating cubic feet into meters, to cubic meter, I mean. So, we'll have here 3.2802 feet in 1 meter. Then, we will cube this. And then, yung ating minutes, ko-convert natin sa seconds. In 1 minute, we have 60 seconds. Okay, so this will be equal to 0.00063 cubic meter per second. Okay, so may value na tayo ng ating flow rate. Kunin na natin yung ating velocity. Our velocity is equal to flow rate divided by area. Okay, so our flow rate is equal to 0.00063 cubic meter per second over our area, which is 0.00216 square meter. So finally, doing this calculation, we will get our velocity as 0.29167 meter per second. Okay, so kompleto na yung mga values natin. Makakalculate na natin ngayon yung ating Reynolds number. So our Reynolds number is equal to rho dV over mu. So substitute natin yung mga values natin. So we have our density, which is 996 kilogram per cubic meter, times our diameter, which is 0.0525 meter. And then our velocity, which is 0.29167 meter per second. Okay, and this is all over our viscosity, which is 8.007 times 10 to the negative 4 kilogram per meter seconds. Okay, so check natin kung makakancel lahat ng ating units. Cancel ang ating kilogram. Cancel ang ating time, which is second. And then, yung ating cubic meter will be cancelled out because we have from our diameter, from our flow rate, in our velocity, I mean, and from our viscosity. So, all of our units are cancelled out. So, from here, if we calculate this value, 996 times 0.052 times 0.9167 divided by 8.007 times 10 to the negative 4 is equal to 19,047.6. This is our final answer for the Reynolds number. Therefore, since this is greater than 4,000, our flow is turbulent. Well, that's all for now guys, and thank you for watching. Please subscribe to our YouTube channel and click on the notification bell para lagi kayong updated sa mga videos na i-upload namin. Please subscribe sa aming website, which is www.engineers.org. It is an online community for Filipino engineers, engineering students, and STEM students. So that's all for now guys. Thank you and have a nice day.